In this section, we're going to be solving word problems. The word problems will all have to do with rational expressions, which, if you remember, rational expressions are things that look like fractions but have x in the top and bottom. So we're going to be taking those kind of problems and solving them. So just some key things to keep in mind. You'll find these in your notes. The acronym CUBES is a word problem strategy that you may or may not be familiar with, but it says that first, circle any numbers you see, underline the question, which is going to give you your variable, and then box any keywords. Also, sometimes they will try to confuse you, so the E stands for to eliminate any unnecessary information, anything that is maybe just giving some background information or isn't relevant to the question. And then you're going to solve your question, drawing pictures, making variables, setting up your equation. So our first problem has fractions and word problems. So let's read through it. For word problems, you should probably read through several times. So example 1 says, the denominator of a fraction is 8 more than the numerator if both the numerator and denominator are increased by 3, the new fraction is equal to 1/2. Find the original fraction. So that's a lot of math terms. So I'm going to go back through and try and break it down. So the first sentence says, the denominator of the fraction is 8 more than the numerator. So my cube says to circle the numbers. 8 more than. Now I'm thinking some key information is going to be that the denominator and the numerator. So that first sentence says the denominator of the fraction is 8 more than the numerator. So I'm going to set that up. The denominator, that's on the bottom. Numerator, oops, not numerator. The numerator is on the top. So the denominator of the fraction is going to be 8 bigger than the numerator. So I'm going to let my numerator be some kind of x, and my denominator is 8 more, so it's going to be 8 plus x. Now you could set that up as x over 8 plus x, or x plus 8 on the bottom. Order doesn't matter for addition. So that's what my first sentence says. The second sentence says, if both the numerator and denominator, so there I see those words again, both the numerator and the denominator are increased by 3, the new fraction is equal to 1/2. So I know I'm going to have something equal to 1/2. But the beginning of that sentence says that both the top and bottom are increased by 3. So that means increased by 3. And then it tells me the new fraction is equal to 1/2. So my question, my U in cubes, says find the original fraction. And remember, the original fraction is x over 8 plus x, because that's what it tells me in the first sentence, that the denominator of a fraction is 8 more than the numerator. So that is the original fraction. Alright, so now I'm going to simplify things up and solve it from there. So I've got x plus 3 on top. I can combine 8 and 3 and get x plus 11 equals 1/2. Now because this has a fraction equal to a fraction, I can cross multiply. So I'm going to do 2 times x plus 3 and 1 times x plus 11. Now I'm going to solve that, so I'm going to distribute my 2, 2x plus 6 equals, I don't really need to distribute the 1 because it's not going to change anything. Move over my x's. I get x plus 6 equals 11. I can move over the 11 and get x minus 5 equals 0. Now I'm still working on solving for x. So x equals 5. Now that is not quite my answer. Remember, my answer, my problem I'm trying to solve is find the original fraction. This thing is the original fraction, x over 8 plus x. So I need to plug in my x to the original fraction, and that's going to give me out my final answer. So I'm going to take this, plug it in. So I'll have 5 over 8 plus 5, which will give me 5 over 13. So that is my final answer. Not x equals 5. My final answer is 5 over 13. So my second example is Miss Moore has quit teaching and become a carpenter. She can build a patio cover in 5 hours. Her competitor, Carl the carpenter, can build the same patio in 7.5 hours. How long would it take them working together to build the same patio cover? So this is dealing with work. So the first thing I need to do is figure out kind of my numbers that I'm working with. So if you remember our cubes example, we want to circle the numbers, so 5 hours and 7.5 hours. We want to then underline the question, which is how long would it take? Then we need to box any keywords, and I'm thinking that a keyword is probably working together and build the same patio. That tells me that I'm going to take these two numbers and stick them together. So I gave you a table. This hopefully will help us get everything set up right. Before I do anything in here, I have to get a variable. So my variable is going to be x. Let x equal number of hours working together. So there's my variable. X is the number of hours when I'm working together, which is what I'm looking for. How long would it take them to work together? So your question is always going to give you your variable. Whatever your question asks, that's most likely going to give you your X or your variable. So now let's fill out this table. So first I'm going to do my time. So Miss Moore, my time working in hours is 5. That first sentence says, or second sentence says that she can build a patio cover in 5 hours. Now I want to find my part done in 1 hour. So that's going to be 1 hour out of the 5 hours. Now let's look at Carl. So Carl says that he can build the same patio in 7.5 hours. So he's a little bit slower than me. So 7.5 hours. So his part done in 1 hour is 1 over 7.5. Now I want to know how long will it take us both. Now that I don't know that. That was what I set X to be. X is the number of hours working together. So let's change colors. X is the number of time in hours. My part, or our part done, would be 1 over x because we are working together, and x is the hours I don't know. So the way I'm going to set this up is it's my time plus Carl's time has to equal our time together. So I'm going to have this column right here. So in 1 hour, I will work, so since we're working together, I've got my time, 1/5, plus Carl's time, and that has to equal our time working together. Because his part in an hour and my part in an hour have to equal our time in an hour together. So now I need to just solve this. Getting to there is probably the hardest part. So I'm looking at all my denominators. I've got 5, 7.5, and x. Now they don't have anything in common, so my LCD is going to be 5 times 7.5 times x, which will give me 37.5x. That's my LCD. So in this section, 7.5 is very similar to 7.4 in terms of you're still solving, so I'm going to multiply every single thing by the LCD. So I've got my equation. 1/5 plus 1/7.5 equals 1/x. And I'm going to multiply every single thing by 37.5, 37.5, 37.5. Oh, x. Sorry, 37.5x. So that's my LCD. Now, if we did the right LCD, my denominator should cancel. So 37.5 divided by 5 gives me 7.5. So right here, 37.5 divided by 5 is going to cancel and give me 7.5. Now I'll still have that x in that one. So the next one, 37.5 divided by 7.5, cancels and gives me 5. And then the last one, just my x cancel. So what I have left over is 7.5x plus 5x equals 37.5. So now on the left, I've got two like terms. I've got 7.5 and 5x, so I can combine those, add them, and get 12.5. Now I'm going to solve it. Get x equals 37.5 divided by 12.5 will give me 3. So that means together, us both working on the same patio, it will take 3 hours. That is your final answer. So my last example says, on Lake Bowen, a person can row his kayak 5 miles per hour. On a nearby lake, Lake Greenwood, it takes him the same time to row 5 miles downstream as it takes to row 3 miles upstream. What is the speed of the river of the current in miles per hour? Okay, so let's go through with my cubes example, And Cube says to circle the numbers. So I've got 5 miles per hour and 3 miles per hour. Those are the two things that I'm given. Now I'm going to underline the question. What is the speed? Speed is another word for rate. So what is the speed of the current? And then I'm going to box any keywords. So I'm thinking that this downstream and upstream is important. Any unnecessary information, the name of the lakes I really don't need. It's just kind of sorting through two different scenarios. So I gave you a hint that said let C be the speed of the current. So off to the side over here I gave you this formula. Distance equals rate times time. Distance equals rate times time. Now I'm going to actually need to find the time. So if I divide both sides by r, that tells me that time is the same thing as distance divided by rate, which is how I'm going to use it in my table. So distance equals rate times time. But know that this last column right here, time, is going to be the same thing as distance over rate. Distance over rate. Alright, so now let's fill in my table. So going downstream, it's going to take me, my distance is 5. Because I'm going 5 miles per hour, my distance is 5. Now the rate, since I'm going downstream, I'm going with the current. So my rate will be 5 plus whatever the speed of the current is, which is what we let C equal. Now going upstream, my distance is 3, because it said that I was going 3 miles upstream. So my distance is still going to be the same rate, because it said it took me the same time, the same rate, but I am going against the current. So I'm going to have 5 minus C. So my last column, I'm going to have, we said over here, that time is the same thing as distance divided by rate. So time is distance divided by rate. And in the one up above, distance divided by rate. 1.25 miles